In this video, we will look at constant of proportionality. Constant of proportionality is integral to the idea of proportional relationships. So before we dive into the meaning of constant of proportionality, let's look at a proportional relationship. What do we have here? We have number of pencils and cost in dollars. And we are given that for 4 pencils it costs $5 and for 12 pencils it costs $15. Now, if you will remember from our earlier video on proportional relationships, the two quantities in a proportional relationship are always in the same ratio. In this case, we can write the ratio as 5 to 4 for the first row. And if you simplify the second row, let's take 15 over 12, and if you divide both top and bottom by 3, that also simplifies to 5 over 4. So this ratio, which stays the same in a proportional relationship, is basically the constant of proportionality. Let's write down the words constant of proportionality. And let's look at the meaning of each of these words. The first word is constant. Constant means it stays the same. It's where you have variables and constants. Constant is what stays the same. So in this case, is the ratio stays the same in a proportional relationship. And the next word is proportionality. Proportionality because it's related to a proportional relationship. So the constant of proportionality, a proportional relationship. So the constant of proportionality is basically the ratio in a proportional relationship. The other way to think about a constant of proportionality is unit rate. Now, in any proportional relationship, there are basically two unit rates. So let's look at the two unit rates in this proportional relationship. We have dollars, so we have $5 for 4 pencils, and we can find the unit rate by dividing 5 by 4, and we will get $1.25 per pencil. And the other unit rate would be if we take 4 pencils and divide that by $5, we would get, so 4 divided by 5, you can write that as 0.8, or you can write 4/5. So 4/5 of a pencil per dollar. Now in this case, clearly the first unit rate makes sense, but the second unit rate kind of doesn't make sense because you wouldn't be going and buying 4/5 of a pencil per dollar. Since with every proportional relationship you actually get two unit rates, the constant of proportionality is more formally defined by independent and dependent variables. So let's look at the formal definition of constant of proportionality. The constant of proportionality is expressed through this formula k equals y over x, where y is the dependent variable, x, as you must have guessed, is the independent variable, and k is simply a letter that is used to say constant of proportionality. So the constant of proportionality is the ratio of dependent variable to independent variable. Let's look at our example of pencils. We have number of pencils and cost in dollars. The cost in dollars clearly depends on the number of pencils. if we buy 4 pencils, we end up spending $5. And if we buy 12 pencils, we end up spending $15. So this is our independent variable. And this is our dependent variable. And if you're finding the constant of proportionality, k equals y over x. In this case, y is cost in dollars. So let's take the first row, $5 over 4 pencils. And if we find that as a unit rate, that would be $1.25 per pencil. So your constant of proportionality, or k, is equal to 1.25. And what that 1.25 means is that it costs $1.25 per pencil. Let's look at another example. In this example, we have Kabir. Kabir runs 10 laps in 25 minutes. There is a proportional relationship between the number of laps and the time taken in minutes. Suppose we decide that the number of minutes is the independent variable, because typically time is considered as the independent variable. Let's write that down, x. So say we decide that your independent variable is time, so that's number of minutes. And in this case, the number of minutes is 25. And your dependent variable, that's y, is the number of laps. And in this case is 10. When we find the constant of proportionality, we have k equals y over x. And in this case, y is 10 laps, over x is minutes, so it's a time in minutes, so it's 25 minutes. And I can simplify 10 over 25. Let me write that on the side here. I can simplify 10 over 25. I can divide both top and bottom by 5. As I can write that as 2/5. And my answer, you must realize, I'm dividing laps by minutes, so my answer is going to be laps per minute. And since my answer is going to be laps, instead of writing as decimal, I'm actually going to leave it as fraction. So it's 2/5 laps per minute. In this case, my constant of proportionality is 2/5, or you can write that as 0.4. And what that 2/5 means is you can do 2/5 of a lap. In fact, I shouldn't even be writing laps. 2/5 of a lap in 1 minute. Now, in this example, it's perfectly valid to actually consider laps as your independent variable, because you would like to find out how many minutes it takes per lap. So let's do this all over again, and let's say that your independent variable now is number of laps, and your dependent variable is time in minutes. And of course, now your constant of proportionality is going to be quite different, y over x, because now your y is time in minutes, and it's 25 minutes over 10 laps. And since I'm dividing minutes by laps, my answer is going to be minutes per lap. And I can simply divide 25 by 10 and write that as 2.5 minutes per lap. So how you define your independent and your dependent variable will decide what your constant of proportionality is. So in this case, The time in minutes is your independent variable, so your constant of proportionality is 2/5 of a lap per minute. But in this case, your independent variable is the number of laps, so your constant of proportionality is 2.5 minutes per lap. Let's recap what we have learned about the constant of proportionality. So the constant of proportionality is the ratio or the unit rate in a proportional relationship. And this ratio or the unit rate stays the same or stays constant throughout the relationship. Constant of proportionality is more formally defined or expressed through the formula k equals y over x, where y is your dependent variable and x is the independent variable. So the constant of proportionality is essentially the ratio of the dependent variable to the independent variable. And going back to the example that we first started with, if you have k equals y over x equals $5 over 4 pencils, you get a constant of proportionality of 1.25, and that 1.25 means $1.25 per pencil. In the next video, we will look at how to identify the constant of proportionality when we are given a graph.